Hello friends, I am Chandan. So today's topic is entropy generation. Okay. So in last lecture we covered that. So here in last lecture for reversible process we complete that that is dq by t for reversible process. So we know that ds for reversible process that is equal to del q by t. Okay, we know this formula for reversible process, and for irreversible process uh, ds that is equal to uh, del q by t for irreversible plus delta s. So delta s basically it is an entropy generation. Okay, so now consider here this is y-axis, and this may be pressure, temperature, volume, and this is x-axis, and this may be any property, that is enthalpy, entropy. Okay, so here this point here, this point is the state 1 and this point is the state 2. Okay, so consider there is a process from state 1 to state 2, and and there is another process that is state 1, sorry, state 1 to state 2. Okay, and there is another process that is state 1 to state 2, this is process c. Okay, so now consider this process a, that is this process a is a reversible process, and process b is the irreversible process, and process c is also irreversible, but this c process is more irreversible than process b. Okay, c process is more irreversible than process b. Okay, now for process a we know the formula for process a, dq del q by t for process a plus delta s, and the for reversible process this delta a that is equal to 0. Okay, because we know that for reversible process this is the formula, that is for reversible process ds that is equal to del q by t for reversible process. So there is no entropy generation. Okay, there is no entropy generation, so entropy generation that is equal to 0. Okay, so that is why this term that is equal to 0. Now for process b, if you consider the process b, that is ds that is equal to del q by t for process b plus delta b, and for process c ds entropy change that is equal to del q by t for process c plus delta c. So here uh, this is del q a, so delta a that is equal to 0, and here there is delta b and this is delta c. So here remember this, delta c it must be greater than delta b greater than delta a, and delta a is basically 0. Okay, so remember this data, this is very important. So the entropy generation for irreversible process now for process c is greater than for process b, because process c is more irreversible than process b, so that is why entropy generation for process c is greater than process b. Okay, so this is the case, you have to remember this data. So uh, here hence ds ds depends upon path. Sorry, here delta s, this is delta s, that is entropy generation depends upon path. It means the entropy is a property, but entropy generation is a path function. Entropy generation is a path function, that means inexact differential. So that is why del q by t for irreversible it is a path function, very important. Remember this, del q by t for irreversible it is also a path function. Okay. Okay, now there is an example. Okay, there is two axes is there, this is two axis, and this is state 1 and this is state 2, and suppose this is reversible process. And consider for reversible process del q by t, del q by t for process A, that is equal to 10. Okay, that is basically S2 minus S1. Okay, so entropy change, that is basically S2 minus S1, that is equal to 10, and entropy generation, that is equal to 0. Okay, so now there is another process, that is basically a irreversible process, process B, and this process B here, del q by t, del q by t for irreversible process, that is basically 8, and the entropy generation, that is equal to 2. So this, there is entropy generation, that is 2, entropy generation, that is 2. Okay, and there is a more irreversible process, this is process C here. This is going from state 1 to state 2, this is process C, and the entropy for entropy change, that is S6, and entropy generation, that is 4. Okay, so as the irreversibility increases, the entropy generation is also increases, we see this. And there is another irreversible process, this is more irreversible than process C. So here the entropy generation, this is basically 5, the entropy generation, that is basically 5, and entropy change, that is equal to 5, and entropy generation, that is 5. So here we see that in process B the entropy generation is 2, in process C the entropy generation is 4, in process D the entropy generation is 5. That means as the irreversibility increases, the entropy generation is also increases. Okay, so this is the concept here. Okay, now there is a suppose consider this is an universe. So this is our universe, this is our universe, and in this universe, this is our universe. Okay, and in this universe there is a system, there is a system. Okay, system means where our study is focused, and outside this system there is a surrounding. Okay, so this here, this is our boundary, and this boundary, the heat is transferred from this system to the surrounding through this boundary, and heat may transfer from surrounding to system through this boundary. Okay, so basically there is a heat may transfer through this boundary and mass may transfer through this boundary. So this is the external effect, that is transfer. Okay, so delta S, you know that delta S is the internal irreversibility. Remember that this is a internal irreversibility. So if you want to calculate universe entropy change, so the formula, that is equal to del q ds universe, that is equal to del q by t plus delta S. This is for universe, remember this is for universe. Okay, this is for universe. Now, so in a universe, we know that universe is an isolated system, that is why the heat transfer, that is del q, that is equal to 0. So that is why this term is neglected. Okay, so only there is a entropy generation. Okay, so from this equation you can say that is delta S, uh, delta S, you can say that is ds universe, that is equal to entropy generation. Okay, so there entropy generation is there, and entropy generation is positive. Okay, so from here from here you can say that ds universe greater than equal to 0. Okay, and ds universe, this universe is equal to system plus surrounding. We know this, the universe, we know that universe that is equal to system plus surrounding. So from here you can see that ds universe that is equal to ds system plus ds surrounding. Okay, as ds universe greater than equal to 0, from here you can say that ds system plus ds surrounding that is greater than equal to 0. And if it is a reversible process, then ds system plus ds surrounding that is equal to 0. Okay, and if it is a irreversible process, then ds system plus ds surrounding that is greater than 0. So this is very important. Okay, so this is also very important. Remember this: for reversible process, ds system plus ds surrounding that is equal to 0, and for irreversible process, that is ds system plus ds surrounding that is greater than 0. Okay, since universe is an isolated system. Okay, we know that the universe is an isolated system. Okay, now its entropy can change only due to energy generation or creation. Okay, and the entropy generation is only positive or 0. So entropy generation is always positive or 0. Therefore universe entropy never decrease. Okay, so that is why this is known as principle of increasing entropy of the universe. Okay, this is known as principle of, here this is known as principle of increasing entropy of the universe. Okay, so here delta s ds greater than 0 because greater than equal to 0 because of delta s entropy generation, this value will be positive or 0. So that is why this is here positive greater than equal to 0. Okay, so this is the things. Okay, so here remember this two formula, that is for reversible process that is equal to 0, and for irreversible process that is greater than 0. Okay, now in last lecture we cover this adiabatic process. If it is an adiabatic process, there is a adiabatic process. If it is a reversible adiabatic process, and there may be irreversible adiabatic process. So we cover this that is reversible adiabatic process and irreversible adiabatic process. For reversible adiabatic process, if there is some system, this is our system here. Here this is our system, and in this system there is isolated this thing, there is no heat transfer. Adiabatic process, that means there is no heat transfer through this boundary, and this is surrounding. Okay, and this is system. Okay, if you want to calculate the surrounding entropy, ds change in entropy for the surrounding, that is equal to del q by t for surrounding, and as the heat is transfer is equal to 0, so that is why this term is neglected. So from here you can say that ds surrounding that is equal to 0. From here entropy is equal to s1 equal to s2, that is entropy constant. So you can say that it is an isentropic process. Now if we consider this a surrounding, so for system, same formula, that is dq by t for system, and as there is no, this is isolated boundary, here, this is isolated boundary, so that is why isolated, that means isolated boundary. So sorry, this is an insulated boundary. Okay, so that is why this q that is equal to 0. So there, so that ds system that is equal to 0. So from here ds system that is equal to 0. So from here you can say that s2 is equal to s1. Okay, so entropy basically constant. Okay, so you can say that this is an isentropic process. Okay, you can say that it is an isentropic process. Isentropic process, and this is also isentropic process. Okay, and this is also isentropic process. Now if it is an irreversible process, for irreversible process, if you want to calculate for system entropy change, that is equal to del q by t plus delta s, and if this is insulated, so that is why this term is 0. So from here ds system that is equal to delta S, that is means entropy generation. So from here you can see that entropy greater than final entropy greater than initial entropy. Now for surrounding, if you see the surrounding, that is ds surrounding, that is to dq by t for surrounding, dq by t for surrounding plus delta S. Okay. Now as this is a surrounding, this is a surrounding. So here for surrounding irreversible, we have to see that delta S that is equal to 0. So consider this is delta S that is equal to 0 for irreversible adiabatic process. So if it is 0, then ds surrounding that is equal to 0. So from here S2 that is equal to S1. Okay, this is one case here. Suppose consider this is entropy generation that is equal to 0. Okay. So from this case there is a condition that is entropy constant is there. Okay, or you can say that isentropic process, isentropic process. Okay, so there is a note point is that we cover that ds universe that is greater than equal to 0 and ds universe that is equal to, we know that ds system plus ds surrounding that is greater than equal to 0. So hence only those processes are possible for which the summation of system and surrounding entropy are 0 or greater than 0. Okay. So if the ds system plus ds surrounding is equal to 0, then it is a possible and reversible process. So remember this. And if ds system plus ds surrounding greater than 0, it is a possible and irreversible process because it is greater than 0. So this is an irreversible process. Okay. And if ds system plus ds surrounding less than 0, then it is an impossible process. So this is very, very important. Remember this information. This is very, very important. Okay. So this is all about the entropy generation and what is the entropy. We calculate the entropy for universe and we see that which is possible process and which is not possible process. Okay, so this is all about this uh, lecture, and this is my handwritten notes. You can download it from the description. And there is a telegram group Mechanical Bengali. You can download, you can join on this group for regular update. Like, share, subscribe my YouTube channel. Okay, thank you.